the minerals. So those are the main nutrients. So every food group basically have a particular nutrient or two nutrients that it actually responsible for providing mostly. So let's say for example foods from animals, those that food group basically give you a lot of fat.
Excuse me, sir, I'm not seeing your screen.
You're not seeing my screen.
No, sir.
Yes.
I'm seeing it now.
Okay. Right. So fruits, that's another food group, and definitely there are several fruits. Cherries, we have mangoes, pineapple, banana, guavas. The list goes on in terms of the different fruits. And again, in terms of nutrients, vitamins, and minerals. So once you're looking at the food groups, you basically supposed to know which nutrient or nutrients that particular food group is known for in terms of giving it nutrient. So as for vitamins, we have two food groups that will provide you with, the amount of vitamin that the human body should need, which of course would be vegetables and fruits. And the energy value of food. Now, this what you're seeing to the right of the screen is actually a labeling that will be on a product that definitely is a food product. So on these labeling, we normally see the percentage as to the different nutrients. As you can see down the bottom, it is saying that it is 30% calcium. So that means that it is high in terms of calcium. As for protein, it is 17% protein, carbohydrate 4%, sodium 5%, and sodium would be an example of a mineral. As for cholesterol, they are saying 0%. So once you look at the labeling for food products with chips, just about anything that you would purchase to eat, it's supposed to have the amount of different nutrients that actually in that product. So they are saying that most of the food we eat is used to provide energy. And that is definitely simple because human body need a lot of energy to actually keep going during your lifespan, even if you're not doing anything strenuous. The mere fact that your body parts are working definitely mean that they're gonna need energy because energy is what keep them going. So as for energy, we have more than one nutrients that are responsible for giving us energy. We have carbohydrates to give us energy. We have fats that also give us energy. It is just that in terms of depending, even though fats give us some amount of energy, it's like the human body don't depend on fats mostly. The human depend on carbohydrate mostly, and one of the reasons for that is that carbohydrates normally take a faster time to digest than fats. Because you'll hear a person said that food take up to 3 hours to digest. Now, if the food don't contain a lot of fat, then it will not take so long. Simply because there is no fat. Now, just like whenever you're washing the dishes, if you're washing some dishes that contain oil, I'm sure that it is much more difficult to wash those dishes instead of in comparison to you washing like some cups that don't have any oil in it. And that is simply because the fat molecules in terms of the water and the soap that you're using to wash the plate, it take a longer time for the fat molecules to be broken up by those cleaning agent that you would be using, whether you're using soap alone or you're using a little bleach with it. So it is the same thing in the human body when you consume fat. Fat take a longer time to digest simply because the particles, the components that make up fat, they actually take a longer time to be broken down by the different enzymes or the different chemicals that help in the digestive process. So the second point is saying carbohydrates provide energy quickly, while lipids, which is the same thing as fats, are longer term energy source. So energy that the human body need quickly, right away within a few hours after you eating, then the human body will get that from carbohydrates. But as for the fats still gonna give us energy, but they are saying that it is for a longer term energy source, and that simply means that fat take a longer time to digest. So that's why the human body depend on carbohydrates um, mainly for energy. The energy content of food is the amount of energy released when digestion is complete. Right, so and they have to make that very clear so that the amount of energy that you get from the food is basically when digestion complete. So that is whenever they are measuring how much energy you get from a particular food product. Now the reason why they have to say when digestion complete, that is simply because during the process of digestion some amount of energy is also used, because in order for that digestive process to go through or take place, energy is needed. All right, so we have this that is called the energy value of the macronutrients. Now they are comparing the three macronutrients just for you to have an idea as to how much energy they get from each of these nutrients. So they are saying that energy is measured in joules or kilojoules, right? Just like how distance is measured in kilometer or meter. In terms of you measuring energy, how much energy you're using, how much energy you're getting, it is measured in joules, or if you want to say, are kilojoules. So they give you the equivalent 1000 joules equal to 1 kilojoules. Now there was 3 pointers. So they are saying if you're comparing 1 gram of each of these food, so they are saying from 1 gram of carbohydrates you will get 16 kilojoules of energy. So it is 16 kilojoules. So if I should ask you to convert this to joules, then you should tell me that it is 16,000. That is if you are being asked to convert the kilojoules to joules. Because if 1000 joules make 1 kilojoules, then in order to find out how many joules in this 16 kilojoules, then they just multiply it by the 1000. So 1 gram of lipids now, or if you want to say 1 gram of fats, they are saying provide 38 kilojoules of energy. So right away you can definitely realize that fat give you more energy than carbohydrate. Alright, so it is not that you're not going to get the energy from the fat. It is just that it take a longer time to release. So the human body will get the energy from the carbohydrate first. And when all of that energy depleted, then the body will go towards fats and get some of the energy. Because 1 gram of carbohydrate, they are saying, and 1 gram of fats. So the same 1 gram comparison in terms of weight, fats will give you more energy. As for protein, they are saying 1 gram of protein provide 17 kilojoules. And again, so you will realize that carbohydrate and protein basically are the same, because some textbook will give you the same, they will say that protein also provides 16, right? It's just that there is just a slight difference. But as for this one, you're seeing that protein contain one extra, one more. And again, the reason why the human body depends on carbohydrate is because of all the three macronutrients: carbohydrate, lipids, and protein. The energy get to release much faster from the carbohydrates. So that's why the human body depends on carbohydrate mostly to provide energy. So you'll realize that it is not like carbohydrate is what provide most of the energy, just that the body depend on it mostly. So when the body would have used up all of the energy from the carbohydrates, then that is when it will actually get some from fats and definitely get some from protein. So last point down the bottom there, foods that are rich in lipids normally have the highest energy content, as lipids provide more than twice as much energy per gram as carbohydrates and proteins. And you can see that easily by looking at the figure, because 16 and 16 give you 32. So, and the note is saying provide twice as much. 17 and 17 give you 34. So if you multiply any one of those by 2 with a carbohydrate or protein, still not going to give you the amount that fats or lipids give you. So definitely fats give you a lot of energy. All right, so how much energy do we need? So basically we're looking at this chart here, just comparing persons in terms of their different job. So it all so persons energy on a daily basis all depends on the type of work that you're doing. If you're somebody who's involved in construction work versus somebody who work in the bank, I'm sure that the construction work are gonna consume, are gonna use a lot more energy than the one that work in the bank. So this is what they would have done. They just give you an idea of how much energy different type of personnel should consume. So the first one say female, the first one, which is the pink, or if you don't want to say purple, it label is saying female office worker. So this can be no, if you are male, the first one is male office worker and the second one is female office worker. So the yellow one represent the female office worker and the pink one represent the male office worker. Now generally male normally use more energy than female. So that's why you're seeing there's a slight difference between the male and the female, where the male is 10,000 kilojoules and for the female it is about 9,000 kilojoules. So what they are saying that these types of worker, this is the amount of energy that they must consume. As for the builder, so builder definitely are like construction worker, and they realize that feet gone way up at 20,000. So the amount of energy that you need all depend on the amount of work that you have to done in terms of, manual or physical work. Then we have the pregnant woman also up there. She should be approximately 12,000, and that is simply because she is not only, the fact that she is pregnant would mean that she is catering for another human being, and that developing fetus definitely cannot feed by his or herself, so definitely gonna need some help. So the pregnant one, they are saying that she stand at approximately 12,000. Old woman, you got that one gone way down at 6,000, and that is simply because the person is old, they're not doing anything strenuous, so they don't need a lot of energy. Then we have the male teenager gone back up about 15,000 thereabout. So generally male teenager around the age of 13, 14, 15, and you will realize that at that particular time, boys are really normally active during that time of their life. So that is 15,000. And the male infant, so they are saying that stand at 6,000 there. So this this graph is bar chart is basically to give you an idea as to how much energy persons use based on their level, based on the level of activity that are tasks that they have to complete. So in order to lose weight, the body must transfer more energy from its cell than it is taken in when eating. So definitely they are saying that to control the body weight, whenever you're eating, you must not eat in excess. So if you eat in excess, that's when you normally increase body weight because you eat too much. But if you not eat in excess, then basically the body will always want fat and other nutrients to come inside because there is always a shortage, and that is the space that you want to create. You better you have a shortage than have too much, because having a shortage means that you can definitely get something. But when you have too much, I mean that's it. As you get older, you require less energy because your metabolic rates slow down. Right. So as an individual get older, in terms of the amount of energy, then they're not gonna need so much. And older in the sense, not at your age, we were talking about when you reach your adulthood, like 50 at 60 at. As you reach those stage, the amount of energy that you need normally get less or decrease. So young people need more energy for the reaction in their body to make new proteins for growth. So the fact that young persons normally growing. So the fact that they're normal growing, then definitely they're gonna need a fair amount of energy. So the amount of energy a person needs each day depends on their age and gender. Age and gender. And so the age and the gender. And as for this one, it can also depends on the type of activity that they are doing. Because if the activity is not anything strenuous where they are lifting some things or carrying weight, then they don't need a lot of energy. So it all depends on the activity. Right, and balanced diet, of course, we would have got balanced diet, and a balanced diet one in which a person receive the right amount of the different nutrients the body need to stay healthy. Right. So the balanced diet, don't give a definition for balanced diet and saying that it is whenever the diet contain equal amount of every nutrients. No, because I would have already made it clear based on the second pointer there in terms of going through the percentage. So they are saying that whenever you have a meal in front of you and plate in front of you with some food, 55% of that plate should contain carbohydrates. So if you eat food like in dumpling or yam and banana, then 55% of the amount that you're eating should be those food. Those food contain carbohydrate. Lipids, so that would be fat. So you eat a piece of chicken, so that should be 15%. And the protein, now you get protein from meat product also. They are saying 20%. And you get protein also from like beans and peas. And they are saying now, as for the other 10%, now that should include your water, that should include your vitamins, and definitely your minerals. So you realize that that small 10%, that simply means that you don't have to eat an entire plate of vegetable, because the human body don't need so much. Only 10% of the diet is shared between these vitamins and minerals, and definitely water. Right, malnutrition. So malnutrition, this is when, or this occurs when a person does not receive sufficient of one or more food groups. It can also occur when they eat too much of one or more of the food groups. Right, so malnutrition is basically, in a sense, you're not receiving the right amount of nutrients. So you can be getting too much, and you can also be getting too little in terms of them. So once that is happening, then definitely malnutrition is taking place. So protein, energy, malnutrition. So starvation causes PEM. So PEM is the abbreviation for protein, energy, malnutrition. Lack of it, if you're not eating enough protein, then kwashiorkor is the disease that will affect you. And this is whenever the person belly is swollen or the abdomen is swollen with less muscle and slow growth rate. So if you're not eating enough protein, there are a lot of things that can affect you. In terms of your muscles, it will slow down or your muscles are growing. In terms of weight, in terms of size, So some of the time whenever you see some individual short and look like they don't grow, it can be as a result of them not getting enough nutrient, so because if they're not getting enough nutrients, then definitely they will not grow at the rate at which they will grow. But let's say, for example, the person should change environment, change home, and start to live somewhere where yes, they're actually getting good food. Then all of a sudden, you just see them start grow a lot, right? Because protein is a main nutrient that is responsible for growing of the body parts, repairing of the body parts. Protein is a nutrient that is most responsible for that. All right, additives. Now, this term now, as for food products, like for example, the chips and the juice, them wanna buy at the shop or supermarket. Now, there are a lot of chemicals that are placed in those products. So we're going to look at what are known as additives. So this is when substances are added to food for different reasons. So a plantain chips, for example, if you fry out plantain chips from home, it's gonna be different from the plantain chips that you would have purchased at the shop or supermarket. And that is simply because at home you buy it you do it for your own purpose. You don't need to resell it, so you don't need to put any additive to it so that it can preserve. Because plantain chips, for example, a fry, it is actually fry, and you will realize how long that can stay on the shelf before it is purchased, and once you purchase, it still can eat. Alright, so diet and sport. So once you are taking part in sport, then your diet should change, and that is simply because there would be a lot of protein that will be needed. Because once you're doing sport, then your muscles work a lot. So will definitely need that. So there are two ways in which the body obtain this energy, and we have aerobic and anaerobic. So the sport person generally use more energy, and that is simply because of the high level of activity that they are doing. Definitely will need more than you, John. Alright, so as for the release of the energy, we have aerobic and we have anaerobic. So basically, for the anaerobic respiration, energy is released from glucose without using oxygen. So this simply means that the energy is released really fast. So there is no oxygen that is needed, and so the fact that oxygen is not needed now simply means that the process will be fast, because the energy release system don't need to wait on your respiratory system to take in the oxygen, etc., etc. So organisms that live in air where there is no oxygen use anaerobic respiration to release energy. Right. So once there is no oxygen, then at least them definitely have to use that one to release the anaerobic respiration. So organisms that live in area where there is no oxygen use anaerobic respiration to release energy. Anaerobic respiration take place in the cytoplasm of the cell, because it is almost that I know exactly where it take place. So the last point of there, anaerobic respiration takes place when the body has a different have a sudden large demand for energy. So like when sprinting, for example, because just before the sprinting race, then the human body would want a lot of energy, but soon as enter into the race, then definitely will need it. So as for the anaerobic respiration, it produces energy. Not only it also produce what is known as lactic acid. This causes muscle fatigue and cramps. So lactic acid can build up inside your muscles. So that's why as sport persons normally it is advisable to massage the leg region there to prevent the muscles from cramping up, prevent them from fatiguing, because obvious that obvious that there is a circulation problem, which make the muscle stop working properly. So the muscles not so whenever somebody is experiencing that, then definitely the muscle not working properly. So what now? The buildup of the lactic acid in the muscle can be removed by reacting with oxygen. So when I take in a lot of oxygen, then the added additional amount of oxygen that is in the body can definitely move towards it. Hence, during anaerobic respiration, the body build up oxygen depth. So build up oxygen depth mean that yes, there will be after the respiration there will be limited amount of oxygen because it would have been used up. The amount of oxygen need to metabolize lactic acid is definitely a lot. So during the recovery period after a race, so recovery period is whenever a race finish and you're actually resting. That is called the recovery period. So a person breathe deeply to take in as much oxygen as possible. So you'll realize that if you're running for a long while, once you stop and breathing heavily, then definitely the fact that you take in oxygen, it will actually get rid of the lactic acid there. So energy food for our sports persons. The body must have a good supply of glucose to provide the needed energy for exercise. So this is provided in the short term by food rich in carbohydrate. So yes, the human body wants to need some energy right away, then carbohydrate does that. But if it is after a while, the fact that it is in your system, just gradually working, gradually working. Like, give me 2 minutes away from the screen. Just about 2 minutes from the screen. Alright. So once you're a sport person, then definitely you have to consume a lot of carbohydrate to give you that energy quick, especially during competition or if you're having a match or a race, etc. So the glucose tablets that can also be used, so that is in a pill format, and drink. So we have energy drinks that can boost the amount of sugar that is in the body, and that would be like Gatorade and definitely Lucozade. So there's those juice they are normally called energy juice, simply because the carbohydrate that they contain is glucose, and glucose is a type of carbohydrate that can easily be broken down in the human body so that you can get the energy quickly. The last point, this is of limited use as glucose does not stay in the bloodstream very long. So during the race, a primary school, for example, they would give you some glucose in the hand middle, and that definitely help you because the glucose allow the energy to actually go in the bloodstream very quickly. Just that definitely it does not last for any long time. So if you're taking part in sport, yes, in the morning when I get up, it is advisable that you have, healthy breakfast. If you have lunch, healthy lunch. Because let's say, for example, the match that you're playing is in the afternoon. Then from morning, you actually eat a lot of energy food. Because the human body have places where it can store it. It can store it in your muscles and it can store it in your liver. So there is always place in the human body where the excess energy can store. Water and exercising. So when exercising, the body sweat to cool itself, which will keep the body temperature constant. So 37, 38 degrees, that is normally where the normal body temperature should be. But definitely if you're taking part in sport, then that going to increase. So to maintain it, then water is very important. So the blood normally become concentrated if you do not drink water during or after exercise. So concentrated means that the blood will have in a lot of nutrients or a lot of solid substances more than water. So that is why they said that it is concentrated. So because you're losing water by sweating, then you definitely need to replenish that water by ensuring that you're constantly drinking enough water. The kidneys will reabsorb water if you are not drinking enough. So what this is saying is that instead of the kidneys allowing you to urinate a lot of water, then the kidney will actually ensure that some is remained in the human body, so that if you get hot, then the sweating process will at least try to cool you down. So about 6 liters of water must be consumed daily, they are saying. Right, so about 6 liters. Right, so after looking at the nutrients them now, so digestion, that's the next concept. So finish with the nutrients them, so the digestive process now. So in terms of the process, starting from start to finish, for you to get the nutrients, the energy from them, then there must be a process. So digestion, in defining it, it is breaking up the food we eat into smaller particles. So that's what the first point that they are saying. Because let's say, for example, you have one dumpling and you cut that dumpling into 4 pieces. Just swallowing one of the pieces like that not going to help. Simple because it is so large, the human body will not be able to get the nutrients from it. And even if they get the nutrients, it's gonna take a long time to actually penetrate the thickness of that piece of dumpling. So that is why chewing is very important. When you chew on, then the dumpling cut up into smaller pieces. And of course, definitely them in smaller pieces, the energy, nutrients can come out of them much faster. So there are two types of digestion. So we have physical or mechanical digestion, and definitely we have one next one that is called chemical digestion. So as for the types of digestion, we have physical and mechanical is the same type. So physical and mechanical digestion is the same type, and then of course we have one that is called chemical digestion. So if you are being asked to give the types of digestion, the two types, you will actually tell me physical digestion and chemical digestion. Or you can say mechanical digestion and chemical digestion. So the reason why you cannot tell me physical digestion as one type and mechanical digestion as a two type, second type, is simply because they are the same thing. So physical and mechanical is the same thing. So the process of breaking down food in the mouth into smaller pieces that can be swallowed. So that chewing movement, chewing motion by the mouth, that is an example of a physical or mechanical digestion being done. So as for the physical one, so chewing, so I can ask you to give me examples of the different types. So one example of physical digestion is chewing. So chewing the food, that is one. So they are saying chewing is the initial, so that means the first mechanical breakdown of food. Strong muscles of the stomach also break up the food. Now, the images that you are seeing, those represent the stomach. Now, once the food enters the stomach, there are some muscles that normally contract and relax, and they actually cause a churning movement. So that means that this movement is actually causing the food that is in the stomach to mix up with some juice that would normally produce by the walls of of it. Gastric juice is the name of the juice. So once the juice is produced and the food start to mix and mix, then the food will actually get smaller and smaller in terms of the particles. So if I should ask you to give me two examples of physical digestion, then you can tell me chewing by the mouth, that is one, and then churning that take place in the stomach. So the last point I know, giving you the main reason. So breaking down the food gives it a larger surface area for a digestive enzyme to work on. So the digestive enzymes are some chemical that speed up the digestive process. So what they are saying is that when the food particles, when they are broken down into smaller pieces, then the enzyme can reach them much faster. The enzyme can reach the inner components of those nutrients, and that makes sense because if they are large, like for example one big piece of dumpling, then the enzyme will take a very long time to penetrate it because the particles they are not small enough. Alright, so we have mechanical digestion is the first step in the digestion of the food you eat. So definitely the fact that the first once you put the food in the mouth, the first thing you're gonna do is actually chew. So that is why they are saying that mechanical digestion is the first step. As once you plan to eat some food, you can go around putting it in the mouth. As that's where it will be start to cut up into smaller pieces by your teeth. Alright, so the second point are the major parts of mechanical digestion are the chewing of the food and the peristalsis. Alright, so what is peristalsis? Now you're seeing on the screen now peristalsis being explained. So This diagram, for example, would represent the alimentary canal or the digestive tract. For example, between the back of the mouth and definitely down the stomach there. So, in terms of the movement of these food substances, we normally have muscles working together to actually push the food along. Because the food going through what you call the throat there, which is the esophagus. The food need to be pushed along because it's not just gonna drop down in the stomach like that. No, something need to push it along, and that's where some muscles come into play. Where we have circular muscles and we have longitudinal muscles, meaning that the muscles contract to actually help to push the food along. So they are saying that the involuntary movement of the muscles of the esophagus. So it is the muscles within that esophagus that will help it to contract. So looking at the image to the right, you will realize that we to the left, I should say, and you will realize that the what appeared there to be the bolus or the food, it is going downward. So the muscle around it actually squeeze inward. So that means that it is generating the contract to push it along. And that's just like how whenever you purchase cheese in those small polybags and you pour it and then you squeeze it out. Now that's the same principle where the food is actually squeezed by that process that is called peristalsis. So after looking at physical now, then now it is the next type of digestion, which would be chemical digestion. Because remember I said that we have two types. We have physical, or if you want to say mechanical, and we have chemical digestion now. So chemical digestion is required to process and extract nutrients from food that the body needs. So very important in order to get the energy from some of them, then definitely um, need to use a chemical process. The first step of chemical digestion happens in the mouth when saliva combines with food to begin the breakdown of large food molecules. So once you're chewing, that is physical. Now the fact that you're chewing on and the saliva in the mouth now is now combining or mixing up with the food now. So they are saying that the first step of chemical digestion happen in the mouth, right? When saliva combines with food to begin the breakdown of large food molecules. So the majority of the chemical digestion occurs in the stomach. So chemical digestion mostly take place in the stomach. Just a small amount would happen in the mouth, and that small amount is definitely the fact that saliva will mix up with the food, and the food literally don't stay long in the mouth. We have another point that is saying chemical digestion makes food easily absorbed by body cells. So chemical digestion, once the food goes through that process, then the nutrient can be absorbed much more easier by the body cells which would need them. Chemical digestion is made possible by a digestive enzyme. So again, we have some chemicals that are called enzymes. So they are saying that these enzymes, they are what make the process much faster. They are what make the process, much reliable. So the chewing chops and grinds food into small pieces. So this is what takes place in the mouth. And once the food is grind, then are chopped into smaller pieces. then this increases the surface area on the food for chemical digestion. So increasing the surface area mean that because the particles spread out more, then they can actually reach. It can actually allow the enzyme to reach the particles much faster, so the process definitely will speed up. So here we have a slide here just showing us some things that happen in the mouth. So the saliva moistens the mouth and softens the food with mucus. So saliva have some very important role. So saliva moistens. So in terms of moistening the mouth, it makes the food more slippery, because definitely it will digest or go down into the stomach much faster. Now they are saying that there is also something that is known as mucus, and that also makes it slippery. So the tongue then forms a ball called the bolus. Right. So once you're chewing, once you're eating, if you notice, you'll realize that the food kind of fall up in a round situation. So that is because um, the tongue now, once you're eating, the tongue would roll it into a bolus. The ball that is called a bolus. So what happens in the mouth? The first one is saying grinding of bolus by teeth. Then we have salivary glands produce saliva. Right, so definitely, as for the saliva glands, we have more than one area where it is located. So the whole process of swallowing now. So this is how food pass from back of the mouth to the esophagus. Right, so from the back of the mouth they are saying. So the food again roll into a ball that is called a bolus. Then definitely the tongue will push it back of the mouth. And the back of the mouth is also known as the pharynx. So food, once all of that is done, then the food eventually would enter the esophagus and eventually enter the stomach. So we have peristalsis being explained again. So this represent the esophagus. So looking at the section of the image to the right, you'll realize that I see the labeling bolus. So that means that the food would have been chewed and it reached right there. It labeled as bolus. So in terms of pushing the food along the section where you see in the middle where it kind of go in, once it go in, that simply means that the muscles they are contracting, and once they are contracting, then they will generate the force of help to push it along. So peristalsis is normally the wave-like action. Alright. So the esophagus have circular and longitudinal muscles, so it is the circular ones that are contracting at the top to actually push it. Have circular and longitudinal, so they are saying that definitely have some long one. Muscles contract and relax alternately. Now, of course, that's the facts, and there are different reasons. This force food along the esophagus, so need to start that swallowing process. So some bulk is normally needed in the day to allow proper grip by muscles of the digestive tract. So this is the peristalsis being further explained. Alright, that so digestion, stomach slash small intestine. So in the mouth, definitely would have gone through what happened in the mouth in terms of chewing and in terms of the saliva making the food slippery. So now moving on to our next body part, which include or which is known as the stomach. So as to what take place in the stomach when it comes out to digestion. The food enter the stomach definitely from the esophagus. Definitely. Now the food normally stay in the stomach until it reaches a liquid format. So you see that churning action I was talking about in terms of muscles contract and mixing the food. That's what they do. Mix it until the solid food actually become fluid, become liquid, because it is much easier to travel to different body parts. So food then move to the small intestine. That is after it would have spent approximately like 2-3 hours in the stomach. As for roughage now, and that come from vegetable and some fruits, so they are saying that roughage helps the movement of food through the small intestine, and they help in the way that the muscles, whenever the muscles are contracting and relaxing, they definitely need it. Because when the muscles contract and relax, when they grip on the slippery food, then it's like they're not able to hold it and push it along because it's slippery. When they consume the vegetable now, then they can do. Alright, so enzymes, so definitely persons definitely need to do some reading on enzyme apart from what is being presented, because the enzyme very important in the human body, especially when it come out to different um, chemicals. So as for enzymes, so they are saying that these are normally some biological catalysts which speed up chemical reactions in the body system. Acts on molecule called substrate, which is the same thing as nutrients, and change them into one or more product. So these are what we call the properties of enzymes. So any enzymes in the human body, there must be the right environment which all of these are considered, because enzyme they can't work anywhere. So so properties, so they are saying that work best at a certain pH, so whether it is acidic, neutral or alkaline. So what they are saying is that it is very important in terms of the the pH level. The second one work best at a particular temperature. So they actually put the approximate normal body temperature 37 degrees. So they are saying that definitely work best when under that principle into our property. So the next pointer is each only work on one substrate. So let's say for example the enzyme, we have an enzyme that is known as lipase, and that enzyme only work on fat. So lipase, for example, you're not gonna see it, you're not gonna see it working on anything else in terms of nutrients. So protein, whenever protein is being digested chemically, there is a set of enzyme that help to digest protein. Fats, the same thing. Carbohydrates, you don't have one enzyme that work on more than one nutrients. Every enzyme in the human body only work on one nutrient to actually get it digest. So break down large quantities of substrate, right? So the enzyme normally just break down a whole lot. And you'll find that the second to last point I saying they are not chemically changed at the end of the reaction. So what they are saying is that whenever some enzyme work from protein, for example, there is still a lot of energy coming from it. And in terms of changing the chemical component, not going to change. So at the end of the process, everything is the same as for that enzyme. It still work good and it still take picture good, everything. Alright, so chemical in the stomach. So next class will definitely spend some time looking at it in the stomach. So the section which is enzyme properties, it is very important that you read through it more than once and get familiar, because you need to be cognizant of the fact that there are certain environment that must be present in order for those enzymes to function properly. So please ensure that your names are marked in the WhatsApp group. So next class I'll pick up and spend some time looking at the whole digestive process that take place in the stomach. So take care, students.